Now, let's look at some of the promising AI techniques. There are six techniques which we'll be learning. First, let's start with Bayesian network. So, Bayesian network is a probabilistic graphical model with variables and probable influences. Example, calculating the probability of a patient having specific disease given symptoms. Let's say if you want to determine if a patient has coronavirus or not, you can determine the symptoms a patient with coronavirus disease is expected to generate, and then we can calculate and determine using AI if the particular patient has coronavirus or not. Another example would be if a player has a war chest based on what it sees in the production so far. So based on how a player is playing game, you can determine the score of that player while playing the game at the same time, which makes AI exceptionally good at games. It can be good to give a human-like intelligence without cheating or being too dumb. Now that's necessary because AI follows the rules which are provided to itself by human. So we need to make sure that AI follows the rules of the game without cheating or being too dumb. Secondly, another promising technique would be decision tree learning. In decision tree learning, series of inputs are mapped to a particular output. We'll learn about this in further lectures as well. Example, health and ammunition in a particular game. We can predict the bot's survival based on the health and ammunition capability of that particular player. We can modify probabilities based on part behavior as well. So if a player is playing well, it's likely that that player would win the game. However, if a player is playing not as well, they might not win the game. And there's always in between. So probabilities can be determined exceptionally well using AI techniques, which is of decision tree learning. To give you an example, a black and white could stroke or slap, which is a reward or punish type of game, and the creature will learn what was good and what was bad, and it will improve its behavior in the game. The third technique is filtered randomness. You want randomness to provide unpredictability to AI? It would be fun, wouldn't it be? But even random can look odd sometimes. Example, if four heads in a row when tossing a coin, a player will think that something is wrong, and if flip a coin 100 times, there likely will be a streak of 8 heads or 8 tails, and it might seem odd. Probability and possibility are two different things, I might add at this point. To give you an example, spawn at same point in 5 times in a row and then bad. You can perform well consistently, and then you might perform not as well in a particular game. It's completely random, and you have to compare that random result to the past history and avoid losing the game. The fourth type of promising AI technique would be the fuzzy logic technique. It's a traditional set where objects belong or not. Fuzzy can have a relative membership. Example, a binary output, hungry or not hungry, in kitchen, in hall. But what if on the edge? That's where different types of algorithms come into picture and machine learning as well. However, fuzzy logic cannot be resolved by a coin flip, and it is extensively used in games. Example, assessing relative threat of another player. The fifth type of promising AI technique would be genetic algorithms. They search and optimize based on evolutionary principles, good when right answer and not well understood. Example, you may not know the best combination of AI settings to use genetic algorithms to try out, and it's often expensive and it requires a lot of computation power. So most of it is done offline, but now with cloud, it's easier to apply genetic algorithms using cloud. The final technique would be the n-gram statistical prediction. It is one of the best techniques used for natural language processing. Predicting the next value in sequence. Example, if a string is given, shown on the computer screen, next digit could easily be predicted. This cannot be only used for numbers, but it can be used for sentences and keywords as well. We can search backward and values. To give you an example, a street fighting game, a punch, a kick, or low punch can be predicted in advance. Player does a low kick and low punch, then what will be the next move of the player? Based on these patterns, you can make AI predict it will play what particular move at what particular time, which is extremely useful and makes the AI games very, very, very good in comparison to humans. Just to give you an example, Google had created AlphaGo, which was a chess playing game. Now that AlphaGo played with the world's best chess players and beat them to it. Now Google, just for fun and being Google, made another chess player called Alpha, and it didn't train Alpha the way it did AlphaGo. AlphaGo was trained by learning from the best players in the world, and then it beat them at their own game. However, Alpha was given 2 days to brute force every possible way to learn chess, and when Alpha and AlphaGo were made to play against each other, who do you think won? I'll give you that answer in the next slide.